We will resume. Okay. Component attribute and ring pointers. Each data component has its own component attributes. The storage manager uses these in its operation, including reconstruction, knowing how to create components. Charlie and Echo storage nodes store component attributes in the metadata database on the M2 NVMe SSD. The Alpha storage blades store them in the first part of the data component themselves. We won't pay attention to that. These are things like the component's length, capacity used, the component creation and modification times, and the ring pointer, which points to the next component in the virtual object. It points to this device ID of that component. There are object attributes for the files themselves, or the objects themselves are stored on 3 OSDs. Actually, enough OSD, 3 OSDs on RAID 6, 2 OSDs on RAID 5. These are, in addition to the component, these are the entire object's length, the capacity used, the creation modification times, the RAID layout, the object's owner group, the ACL, the parent directory, and some other internal attributes. We don't need to store this on every OSD. We just need to make sure that we store them on enough of the components that these attributes are not lost, so that the attributes have the same redundancy as the file, the object itself. On a RAID 1 object or RAID 10 objects, every component stores the object attributes. Same location as the component attributes. For the Charlie and Echo, that is in the metadata database in the M2 SSD. The object components include the object's map. That is a map showing all the components that store components of this object in order to make it easier for the client to know which OSDs to ask for information, so it can read these quickly, read the different components of the virtual objects and assemble them into a single file. Review. What types of PANFS objects hold both an object's name and object ID? You know, I think I may have taken this out of the training. I'll let you guess. Anybody have any idea?
Oh, it's not. I always say it's no. I can see it. I know the length of the object. Hang on.
It's the directory. It's the directory.
The directory. Yeah.
That's right. The object's name is in the directory. The object ID, the object itself does not know its name.
Does not
Only
know.
the directory has that. In PANFS, is data filled into a previous predefined RAID grid?
No.
Correct. No, it's not. What is the maximum number of components that a RAID 6 file may be missing to be successfully reconstructed?
Two.
That's correct. Be missing 2. What is the maximum number of components that a RAID 5 file may be missing to be successfully reconstructed?
1.
Correct, that's one. What RAID layout is used for PANFS directories?
Mirroring, RAID 1.
RAID 1. Both of those are correct. Is the parity information stored in the same component for each successive stripe in a PANFS RAID 5 or RAID 6 file?
No.
No, it's not. Rotates. Which item writes the parity data in an object stripe? Is it the OSD, direct flow client, or hardware RAID controller?
Direct flow client?
That's right. Direct flow client calculates the parity and it writes it. That's why such high performance. You have a whole lot, usually you have a whole lot of direct flow clients. Which of these decides which OSDs will hold the data components for a particular object? Is it the OSD, the direct flow client, or the storage manager service?
It's the client. The parity.
Uh-huh.
Yeah, and which, okay, wait.
OSD, direct flow client, storage manager.
Okay, whoa, okay, which? Oh, that would be the storage manager service.
That's right.
Yeah.
That is some very low level stuff. That's
Mhm.
got to be under the control of one and only one thing, which is why the storage manager decides that. It creates the components, then it tells the client where the components are. What method does this item, the storage manager service, use to choose which OSDs to create data components on for a particular object?
It chooses randomly?
That's right, randomly. What is the default size limit in capacity used for a file to be striped as a RAID 1 file?
I'm gonna guess 64K. I'm not
That's
really
right.
sure.
That's right, 64K. What happens if a small RAID file, one file grows so its capacity used is greater than this size limit?
It begins striping?
That's right, it's converted to RAID 5 or RAID 6, depending on what the volume configuration is. Which of these persistently stores the component map for an object? Is it the OSD, the direct flow client, or the director?
Director.
Persistently.
Oh, the OSD?
The OSD, that's right. The OSD is the only thing in the PNASA system that persistently stores data except for the realm configuration. The map is part of the object. Objects live on the OSDs. Can an OSD store two different components for the same object?
Just as a question, is the component the 64 KB stripe?
No,
What
the
is the
component
component?
is, go back and look. Okay, that's the 64K. The component is that whole thing.
Okay. Yes.
No. And I didn't explicitly go over this, but each one of these components has an ID. It's similar to the object ID here, only
Right.
instead of device storage manager, it's device 06, and the OSD's data serial number, its logical ID. So there would be no way to address more than one component. And remember here when we ran out of space for the stripe groups, and this example here, we just go back. These are not different components. This is
Okay,
just
that's
writing
what
more
got me.
stuff to the same component. You know, and maybe I should take away that little gap. But these are the same component. This has hardly ever come up in your practice. I just kind of wanted to clarify that. Okay. Any questions on this? We'll come back to it. This is just laying the basis for what's to come. All right, very good.